Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2. We'll present our paper about offshore wind farm south of Java Sea. Before that, this is our team. Next, I will explain about the background of our group focusing on the title of offshore wind farm. Energy needs continue to increase, while fossil energy reserve continue to decline, encouraging humans to continue to develop the use of new and renewable energy. In addition, new and renewable energy is considered to be cleaner than pollution so that it doesn't cause global warming as has been caused by fossil energy so far. Therefore, renewable energy technology is expected to contribute a lot to Indonesia's energy mix. The technology that is widely developed in the world and can be applied in Indonesia in the near future is wind energy. Wind energy is one of the renewable energy sources that can answer alternative energy needs. Indonesia is a country located on the equator, which generally has low wind speeds. However, several places in Indonesia have great wind potential. Coupled with the very large length of Indonesia's coastline and very wet Indonesian waters, it is very possible to use offshore wind energy in Indonesia. One of them is the southern region of Java Island. There is a large energy potential because the wind gusts in the southern region of Java Island are relatively strong. The next will explain by my friend.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Riyad. I'm from Ocean Engineering and my 3-digit last name is 002 because I'm here to explain the objective and the problems of this scientific paper that we wrote. So first of all, it's renewable energy. So our fossil sources are limited for now. Then for the solution, for the purpose, for the objective, we have to get a better new renewable energy source. And that what we trying to do here, we are trying to get a new renewable energy source that is very flexible to put anywhere and anytime. So we have a unlimited energy source, and that is really flexible in terms of quantity. Second of all, southern Java Ocean. So Southern Java Ocean has a lot of potential, but we don't really make it better that much. So in this our scientific paper, we wrote that Southern Java Ocean has a lot of potential, and we gotta make that potential to the biggest effect that we can give to others. So we make our renewable energy sources machines out there that has a lot of potential of winds, and that's conclude the third and last, that is wind turbines. So for this renewable energy source, we are using wind turbines, and we are using wind energy as our renewable energy source. And wind turbines is actually very flexible, unlike others unlike others energy sources like nuclear or nuclear reactor and others that can be placed in ocean and don't have a lot of potential in the ocean. Wind turbines have a lot of potential in the ocean, and we need to make use of that. And the Southern Java Ocean that has a lot of potential in wind energy. So maybe that's all. Thank you.
Okay, next wind turbine. Wind turbine are windmills that can convert the kinetic energy of the wind into mechanical energy obtained from the rotation of the generator. This generator rotation is then used as a tool to meet the needs obtained from the wind energy conversion. Currently, the use of wind energy in Indonesia is still not given much attention. Even though wind energy has many benefits that can be used to meet the needs of life, such as the electricity needs of the community, which are getting bigger every year. There are two types of rotor that are often used, namely the horizontal axis wind turbine and the vertical axis wind turbine. The first is horizontal axis wind turbine. The main axis of this turbine rotates according to the direction of the wind that is parallel to the turbine axis and perpendicular to the direction of rotation of the rotor so that it can rotate optimally. This type of turbine has high efficiency, but requires wind direction because the rotor can only catch wind in one direction. The second is vertical axis wind turbine. This type of turbine has a vertical axis where the shaft and rotor movement are parallel to the wind direction. Therefore, the rotor can catch wind from all directions. Vertical axis wind turbine has a high torque Q so that it can rotate at low wind speeds. This turbine is often used in small-scale electrical energy conversion because it is in line with design development.
So, my name is Aditya. I will explain about electricity. Electricity is defined as a power that arises due to friction or due to other cause of a chemical process. The, the flow of electron from atom to atom in a conductor or an energy that affect everyday human life. This electrical energy is used to drive electronic devices such as computer and other that function to facilitate human activity or work. Electricity is divided into two types. One, static electricity. It is the energy contained in an electrically charged object formed for ex, for example when two substance or object, for example when our hand and balloon are rubbed against each other. This material has a weaker attraction, namely the hand will be attracted by, namely the hand will, will be attracted by electron and stick to the object with a strong attraction, namely in balloon. Two, dynamic electricity is electricity that can move in a series circuit. The voltage depend on the resistance. However, in a branched circuit, the voltage has no effect on the resistance, which all of that has been stated in Kirchhoff law, which read electricity need in Jamali consists of Bali distribution, Java distribution, Central Java Yogyakarta distribution, West Java Banten distribution, and West Java Tangerang distribution. The total electricity demand from the five distribution are is much higher than the electricity demand in other region in Indonesia, which is around 80% of the total national electricity demand in 2003. This is very reasonable considering that Jamal is the center of all activity, but its electricity consumption is still low. The project amount of electricity demand in Jamali from 2003 to 2000, 2020 is shown in graph 2. From graph 2, it appears that the electricity demand in Java is dominated by the industrial sector, followed by the household, business, and general sector. Thank you.
Okay, now we talk about generator. Generator is a device that can convert mechanical energy into electrical energy. The mechanical power for an electric generator is usually obtained from rotating shaft and is equal to the shaft torque multiplied by the rotational or angular velocity. Mechanical energy can come from heat, water, steam, wind, and the others. Electromagnetic generators use an electromagnet. A basic electromagnet generator has a series of insulated coils of wire that form a stationary cylinder called a stator, surrounding an electromagnetic shaft called a rotor. Turning the rotor makes an electric current flow in each section of the wire coils, which become a spirit electric conductor. The current in the individual section combine to form one large current. This current is an electricity that moves from generators through power lines to consumer. The electric energy produced by generators can be AC or alternate current or DC direct current that matter depending on the construction of the generator used by the power plant. Direct current generators produce DC electric current because the construction is equipped with a commutator, usually serves as an amplifier in the main generator in a workshop or industry. While the alternating current generator produces AC electric current, this is because the construction on the generator causes the direction of the current to resolve at every half turn. Generators are closely related to Faraday's law. This is the result of Faraday's law. When a piece of conducting wire is placed in a changing magnetic field, then in the wire will be form electromotive force.
The next one is the aerodynamic forces in wind turbine. So the wind turbine blades are designed to generate maximum power from the wind at the minimum cost possible. The design is driven by aerodynamic requirements, but it must be also compromised to keep the cost of construction reasonable. The aerodynamics of the wind is fundamental to wind turbine design. The power available from the wind varies as the cube of the wind speed. This means that sites have to be selected carefully within the criteria, which is the ideal site criteria is a site with steady winds and a turbine that is able to make the most of the lighter winds while surviving the strongest wind gusts as it varies every second due to turbulence caused by land features, thermals, and weather. These various effects lead to varying loads on the blades of a turbine as they rotate, and mean that the aerodynamic and structural design needs to cope with conditions that are non-optimal. So here you can see is the lift and drag factors of wind turbine blades. So the wind turbine blades work by generating lift due to their shape. The more curved side generates low air pressures, while the high pressure air pushes on the other side of the aerofoil. Well, the net result is a lift force perpendicular to the direction of flow of the air. The lift force will increase as the blade is turned to a greater angle to the wind, which is called the angle of attack. While at the very large angles of attack, the blade will stall and the lift decreases again, so there is an optimum angle of attack to generate the maximum lift. Well, in here you can see the turbine blades at low, medium, and high angles of attack. Well, there is also a retarding force on the blade called the drag force, which is a force parallel to the wind flow and increases with angle of attack. The lift force is much bigger than the drag when the aerofoil shape is aerodynamically good. But in the very high angles of attack, especially when the blade stalls, the drag will increase rapidly. The blade reaches its maximum lift per drag ratio at an angle slightly less than the maximum lift angle, so that the best operating point will be between these two angles.
Next is torque. Torque, or commonly called the moment of force, is a quantity that states the magnitude of a force acting on an object, which causes the object to rotate. Determining the angular acceleration of an object can be related to the equation torque is inertia times alpha. The torque on each particle is due to the next net force acting on the particle. In addition to using the above equation, torque can also be calculated using the following equation. Torque is equal to divide of V square, R square, and lambda square. This also applies to turbine. The amount of torque on a turbine depends on the wind speed and the angle of the turbine. Torque with angular velocity has a relationship with turbine power so that it can be formulated as follows. Power turbine equals to torque times angular acceleration. The torque value increases with the increase in the value of the angle of curvature on the turbine. This means that the larger the radius of the turbine, the greater the torque, but the rotation produced by the turbine is getting smaller. In general, turbines with a vertical axis type especially the Savonius turbine, have a higher torque value than the horizontal axis turbine. The Savonius turbine is capable of self-starting at relatively lower wind speeds. With a larger torque value, this turbine is able to rotate optimally even the low wind speed.
Next, our presentation about Indonesian physiography. Indonesia have a large potential to produce renewable energy. Wind is also one of the renewable energy. Wind can be defined as a movement of air, mainly caused by the differences in pressure and temperature. Wind energy assessment involves the determination of wind speed probability, distribution, wind energy yield, capacity factor, wind farm layout, and finally the levelized cost of wind generated electricity. Wind energy is produced by the kinetic energy conversion. Wind energy also significantly contribute for the emission gas reduction because there is no CO2 that produced during the energy conversion. The electrical energy production is depend on the wind condition that have two seasonal weather patterns. Small one when rain season and large one when dry season. Indonesia have 8791.42 kilometer beach away that is really potential for the wind energy development. Indonesia has average velocity from 2 meter per second to 7 meter per second. With the characteristic, Indonesia is suitable for small and medium wind turbine installation. However, in a certain area, the wind velocity can reach 10 meters per second, depends on its geographical condition. With this condition, wind energy development still less effective. In 2009, installed capacity in the wind energy conversion system in all over Indonesia had been reaching 1.4. All spread across North Sulawesi, Bali, Yogyakarta, and Bangka Belitung, based on the monitoring data from Meteorological, Climatological, and Geophysical Agency or BMKG. The average wind velocity in Bali is 2 meters per second to 5 meters per second. Hence, Bali has potential the development and utilization the search for wind turbine installation.
Renewable energy. It's really undeniable. Every human being needs energy resource, and every activity that is carried out certainly requires resource, whether it's a renewable energy or not. However, the use of energy source is damaging our earth and will have a huge damage in our earth. So to increase that, we need to use renewable energy for maybe make less damage on our earth. So what is renewable energy? Renewable energy is an energy source that comes from nature and can be regenerated freely and can be renewed continuously uh, and indefinitely. Renewable energy can be treated by utilizing increasingly sophisticated technological development so that it can become an alternative energy resource. There's a couple types of renewable energy. So the first one is solar. What is solar? So from the process of capturing solar radiation and the energy or sunlight, then converting into some electricity heat or some hot water to get the electricity. The sun's heat will be absorbed using a solar panel and then convert into electric power. And the second one is wind energy. The wind energy, as we know, wind is some moving air. So by using the moving air, we can create some electronic power. The third one is tidal energy. So it's from obtain the ebb and the flow of the seawater. And then wave energy, it's generate electricity. However, to develop the wave energy requires infrastructure with a relative high cost. And the last one is ocean heat energy. So the seawater has a different temperature between the inside of the sea and the surface of the water sea. So the surface of the seawater feels hot because it is exposed by the sunlight, and the temperature difference is used to generate the electricity
energy using advanced technology. And then, so there's a couple source of renewable energy, and there are several name of renewable energy. So the first one is hydropower, the second one geothermal, the third one biomass, solar power, wind power, ocean heat, waves, and tides. There's a picture beside of that contain of the source of the renewable energy. It's really undeniable that the benefits using renewable energy is has a more benefits beside of some contra, I guess. So there's a couple benefit on it, and the first one is minimize the effect of global warming, because we know the global warming is really massive on our Earth. The second one is unlimited energy source because it came from the nature and can be we can use it continuously and freely. The third one, improving public health, save resource and money, and creating jobs and opportunity for our new generation. This is maybe only a couple benefits that I can explain in here, but there's a couple more and many more that benefits that I cannot put in this presentation. But um, on my case, I'm gonna use some wind energy, and then the, we use some wind power too, and then we're gonna use the platform is offshore, because we're gonna make some offshore wind farm to make more no make less using some unrenewable energy.
Hello everyone, my name is Fadil. My NRP is 5046211021. I'm from Gulfax. Today I'm going to discuss about the conclusion of this topic. So, Indonesia has a prosperous road ahead across renewable energy. One big advantage Indonesia has in its geographic position on the equator, offering immense potential for its renewable energy, especially at wind energy. With a population of over 260 million people spread over 17,000 islands and around 12.6 million households having no access to public electricity, Indonesia has set an ambitious target of quarter of its electrical generation from renewable sources by 2025. Offshore wind farm is a relatively new technology, and there are still some challenges that need to be addressed before it can become more prominent to be practically work, especially at south of Java Seas. One challenge is that the offshore wind turbines are more expensive to build than the onshore turbines. Also, offshore turbines can be affected by strong winds and high waves, which can damage the turbines. Thus, Indonesia still holds the potential to serve as a model for renewable energy deployment, especially for islands nations throughout the globe. I think that's all about from me and my friends. Thank you and have a nice day, everyone.